Oh, hey there, folks. I recently learned how to program in Python, so I made this space game, demo, or simulator as an excuse to teach myself how to use the curses library and multi-threading in Python. So I'm just going to start up and show you the basics of what features this demo has. When we start the game, first thing you're going to see is we are in orbit around the Earth. The Earth is in the upper part of the frame there. On the lower left, it tells you what your reference frame is. So we're currently in the gravity well of the Earth. That V is our vector towards the Earth to point directly at it, and D is our distance away from it. Below that, we have our time scaling factor. So for every second of real time, 100 game time seconds pass. So we are currently a little bit over a half hour of game time. On the right, we have our thruster output and our bearing, which is your direction in terms of which direction you're moving. The big thing that I learned through making this project is that in space, there's nothing as an absolute reference, nothing in terms of velocity, in terms of direction. So controlling 3 dimensions, not only of position, but also of orientation and velocity and rotational velocity it was quite a learning experience. So let's get our thrusters to maximum output here. And we're going to leave Earth's orbit. Once we're out in space and we come under the orbital influence of the sun instead of the Earth, we'll slow down our time factor and find the star Polaris, which I labeled because, again, it's very hard to do anything without a reference frame. So there we go. I also gave myself a little cheat button here. You see it just stops you dead in your tracks in terms of your reference frame. So we are now at the same velocity as the sun. So there's Polaris. Somewhere around here is the Big Dipper. And I think I see it right there. There we go. These stars are all from an actual star catalog. If there's Big Dipper, then Cygnus should be over here. Yeah, there we go. There's Cygnus. If we follow that, we'll get to Cassiopeia, which is right about there. It's kind of hard to see. It's in the middle of the Milky Way galaxy. So if that's Cassiopeia, then we should be able to follow it down to reach, here's Perseus. And then following that down, I forget the name of this constellation. And then there's Taurus. Oh, and that's a great view. We found it real quickly this time. There's Orion. We can see the belt here, 4 corners and the head. So let's fly to something. Let's fly to Neptune. Here's how we have it in view here. I'm going to increase the time scaling factor again so we can get there pretty quickly. It's very easy to overshoot things. I'm traveling to Neptune basically to point out that these things are not just point sources. Everything you see here has an actual size. And for the, whoops, problems with time scaling factors. Okay. We're doing a flyby of Neptune. And if we wanted to, we could try and get our trajectory and velocity just right so we'd enter orbit. At this vector, I think that we'd crash into the planet. Let's find Polaris again, and we'll try one more thing. There we go. Somewhere around here, we have the Big Dipper again. There we go. And there's a binary system where 3 of the stars are, it's a famous binary system, Alcor and Mizar, I think is how you pronounce it. It's actually like 6 stars, I think, all orbiting very closely, but 3 of them are bright enough to make it into the catalog I use for the stars in this game. So let's increase our time scaling factor. Full thrusters will go faster than allowed by physics. We are now at probably faster than, not yet. Soon we'll be at faster than light speed. And you can see we're traveling closer to the star here. In a moment, we should see it resolve to 3 stars. And then they'll go zooming by us. There we are. So if we continue that, we'll go past all the stars in our local neighborhood. And now we're out, not past, pretty far out there, but not past the confines of the galaxy. All the units of length in this game are real. So this is kind of our local stellar neighborhood is right there in the center, and we're starting to see the galaxy. The Milky Way is, I think it's 220,000 light years across. So we are now outside the radius of the Milky Way, looking down at the disk. Let's stop, full stop, and go back in so we can see the stellar neighborhood. So this is randomly generated stars representing the Milky Way in a disk. And the stars from the catalog, even though it's such enormous distances, it's only a very small portion of the Milky Way, as we'll start to see in a moment. There it is. There's every star in the night sky that's bright enough, that has a absolute magnitude, sorry, a relative magnitude of around 4 or less. And you can see that it's just out there in the middle of empty space surrounded by the Milky Way. Really quite small. We'll fly back in towards it. We'll do a flyby of the solar system, and that'll be the end of our demo. There it goes. Well, if you're interested in playing with it, I'll leave a link to the GitHub files on the in the description. Thanks for watching.